Hi, welcome to Project SleepEZ, delivering a non-intrusive and affordable IoT solution for smarter sleep monitoring. We created a localized miniature setup to simulate real sleep behavior. This small model lets us demonstrate different scenarios, like getting into bed, doom scrolling, light sleep, deep sleep, and waking up, all within a few minutes. The data flow from a microbit to the gateway and finally to the Azure Cloud Infra are exactly the same as in a full-scale setup. The bear represents the user, who will be getting on or off the bed in the demo. The bed runner is attached to a microbit to capture movement from user, as well as a pressure sensor at the bottom of the bed runner to capture on and off bed events. The nightstand holds the microbit with sensors and the wave sensor on an ESP microcontroller. We're using a live monitoring website to display the events. It is already capturing data like the room temperature, lighting conditions, and sound level. This data is then fed to the gateway through the microbit's proprietary radio protocol, and our gateway will publish the data row by row into Azure IoT Hub. The IoT Hub will then route these messages to Cosmos DB. Now, the bear will get on the bed. Pressure sensor will capture the entry. To simulate doom scrolling, we will make additional movement on the bedrunner accelerometer. We will then tag these entries as wake. A reminder will be sent to the user to go to sleep. As we leave the bear on the bed and keep talking, the sensors will detect low movement and high volume, indicating that the bear is on light sleep characterized by loud snoring due to muscle relaxation. As we stop making noise, the sound level is reduced and the movement remains low. The bear is tagged to be on deep sleep. In our subsequent phases, we may start to make use of the data on the right captured by the wave, which works by electromagnetic waves and is able to capture breathing and heart rate via sensing micro-movements on the body. In the next scene, the bear is awake and have gotten off the bed again, trigger the FSR sensor to tag as off-bed event. Similar to the reminder, we have set a shortened time frame to trigger the sleep summary. In this example, once about 15 seconds have passed, another notification will be sent to the bear to provide his sleep summary for the past 2 minutes. Now that we have captured a 2-minute data set, let's imagine the test was ran through the entire night. These hundreds of entries will then be aggregated into a full night summary, giving us details like bedtime, wake time, and total sleep time. Environmental data, light room temperatures, are also averaged over all entries to give it a single entry. Sleep metrics like WASO, sleep efficiency, and latency are also calculated for the user. Based on this summary, the website will also highlight what went well in the sleep cycle and what needs improvements. For example, a 4-hour sleep is considered too short. Next, we zoom out by looking at sleep trends. This page compares the user's sleep metrics across the nights, allowing him to visualize his sleep numbers like duration and efficiency, as well as sleep quality metrics over the past month. Zooming out further, we can take a look at a 90 days overview. With these additional knowledge, user may start to visualize and wise up to his sleeping habits. For example, there seems to be a pattern of extra long sleep night followed by a very short sleep night every week for the past 3 months. These kinds of insights can only be possible with extended and non-intrusive sleep records enabled with Project SleepEZ. Finally, we also have a simple sleep history page for user to zoom into specific sleep records for review and also a basic scoring system. In conclusion, SleepEZ is an all-in-one, affordable, and privacy-focused solution that lets anyone monitor and understand their sleep effortlessly.